Okay, so these are some solutions to the midterm. Um, let's see if we can go through them. If you're having trouble reading these on the video, you might go to the website and download this copy. So there's a clean copy there. Okay, so if f of 1 is equal to 3 and f prime of 1 is negative 2, estimate f of 1.3 using the tangent line of f. So the idea here is that you could write down the equation of the line. Remember that the line needs a point, which would be 1, 3 in this case, slope negative 2. So you could write down the equation of the line, or you could say, well, I know I'm starting at my y value is starting at 3, and I have a slope of negative 2. Oh, I'm sorry. My x value is at 1, I have a slope of negative 2. So if I want to move to 1.3, that means I want to move 0.3 units forward. And so if my slope is negative 2, then I'll need to move 0.3 forward and then negative 2 times that downward, so that would be minus 0.6. Okay, so then when I take 3 and I subtract 1.6, what do I get? I get 2.4. Okay, so if you didn't like the reasoning version, you could always just write down the equation of the line. Y minus 3 is equal to minus 2 times x minus 1. Plug in 1.3 and solve this for your y, and you should get 2.4. So notice, right, when you subtract, you get negative 0.6 and then add 3. Okay, this one we want to find f, g, and h such that we can write this capital F here, square root of 1 plus sine of x, as a composition. And so this is really important because when we're using the chain rule, we want to be able to recognize the composition when we see it. Okay, so think of what happens when you put in a number for x. What are the order of operations here if you were to actually compute this? Well, first of all, you'd put in the x, and then you'd apply the sine function to that. And so that's the h. So h of x is the sine of x. Now that's been computed, and then what do we do with that quantity? We take 1 plus that quantity, so that's your g of x, would be 1 plus x. And then finally, what do you do with that quantity? You take the square root, so f of x is the square root of x. Good. So those are the three functions that'll work. Good. For these problems, these are really just seeing if you can rewrite some of these expressions. So for example, log base 9 of x equals 3 halves. What does that mean? That's 9 to the 3 halves equals x. And in fact, 9 to the 3 halves, that's the square root of 9 cubed. The square root of 9 cubed, so that's 3 cubed. So x is equal to 3 cubed, or 27. Okay. In this case, we have 4 to the 3x minus 1 equals 5. Let me write it bigger. Okay, so we can use logarithms now. So you could use a natural log, for example, or you could use log base 4. Log base 4 is kind of nice using analysis, right? Because then you can say, if I take log base 4 of 4 to the 3x minus 1, that just becomes 3x minus 1. And so that would be log base 4 of 5. Okay, and then from there you just add 1 and divide by 3. So log base 4 of 5 plus 1 divided by 3. Good. And then here we have, I don't know if you can see it, 3 to the 2 log base 3 of x equals 9. And so here we wanted to remember what we can do with that 2. The 2 can go inside the parentheses here. And so in this expression, you can rewrite as log base 3 of x squared. Okay, and now if you have 3 to the log base 3 of x squared, that just simplifies to x squared. And so this says that x squared equals 9, or x equals 3. Good. Now we wouldn't use a minus 3 because you can't take log base 3 of minus 3. Good. By the way, you can double check yourself, right? Because log base 3 of 3 is equal to 1. And so this all simplifies to 2, and then 3 squared is 9. Good. All right. Now in this one created a few problems. So if sine of x is minus 0.4, You could take the arc sine of both sides, right? But the problem with that is, what x value are you actually getting, right? If your x is negative, I should say if theta is negative. Let's put a theta here, just so we're not confusing ourselves on the unit circle. We'll convert back to x at the very end. But if sine of theta is negative, where are you in the unit circle? That means you're down here, right? So you're down here at negative 0.4. And so this is the angle that your calculator is giving you. Okay, and so this is the theta here. So if we want theta between 0 and 2 pi, what would you have to do to this angle? You would have to add pi to that. So one of our solutions then is theta plus pi. Okay, now there is another way you can get a sine of theta to be negative 0.4, and that's to have this angle. So this angle right here would be like theta part 2, or theta sub 2. If you know this theta, how would you get this theta? Do you see how you would get that? You would take, this theta is negative. I better be careful here. When I wrote theta here, this theta is a negative number. So if I wrote theta plus pi, that would put me up here. But if I take pi plus this little amount, which is the absolute value of theta, then I would get it. Or I could say pi minus theta. Remember, again, I've got a minus there because theta is actually a negative number. So this is actually pi minus this angle. Okay, so those are our two values between 0 and 2 pi. Good. All right. Continuing on here, a little bit of algebra. Find the limit algebraically. The limit as x approaches 2 of x squared minus 2x divided by x squared minus 4. If I try to plug in x equal 2, I get 0 over 0. So notice that you can factor this. So that's x times x minus 2 divided by x minus 2 times x plus 2. Right, so the x minus 2's cancel. And so you're left with 2 divided by 4, which is 1/2. Good. Definition of the derivative. So f prime of 4 is going to be the limit as h goes to 0 of f of 4 plus h minus f of 4 divided by h. So before you plug that in, go over here and say, what is f of 4? That's the square root of 4, which is 2. And then f of 4 plus h we can't really do anything with. Right? So now we can come over here and plug things in. H goes to 0, the square root of 4 plus h minus 2 divided by h. Now we talked about how to work this in here. We take a plus sign, and the reason we do that is because now the numerator becomes 4 plus h minus 4. I forgot my limit here. And then the denominator becomes h times your denominator here, square root of 4 plus h plus 2. Okay, so the 4's cancel, and now we just have an h over this quantity, but the h's then cancel, so you're left with 1 over, let me rewrite it before I actually compute it, 1 over square root of 4 plus h plus 2. And so if I plug in an h equals 0, I would get 2 plus 2 in the denominator, which is 1/4. Good. All right. And now finally, let's see, p of negative 1 is 1, and the as x goes to minus 1, we want the limit to be 0. So let's draw a picture of what that would look like. So p of negative 1 is positive 1, so I know that there's a point here. But then, as x approaches minus 1, my limit is 0, so therefore the limit is down here, but the point is up here. So then we have to connect our dots somehow. Furthermore, p of 0 is 1, and p prime of 0 is negative 1. And so p prime of 0 being negative 1 means you've got a slope that's coming down like this. And then p double prime of 0 is greater than 0, so therefore it's actually even curving up like that. So you can kind of connect the dots here. It's kind of a tight corner there, but we can get it. And then finally at x equals 1, we want our function to be continuous but not differentiable there. So how about a little point? That would do it. Good. So again, we're kind of focused specifically right here, and then right here, and then right here. Those are the 3 areas that these 3 things corresponded to. Good. Let's see, do we have 2 pages left? Okay. Let's keep going. Sketch a right triangle with angle theta. Length of the side adjacent is x. So theta, length of the side adjacent is x. Hypotenuse length is 1. So therefore the square root of 1 minus x squared, x squared is the angle opposite there, or side opposite. So cosecant of theta is 1 over sine of theta. Let's see, sine of theta is the square root of 1 minus x squared, so 1 over that, 1 over square root of 1 minus x squared. Good. Now for arc cosine of x, so it looks like cosine of theta is equal to x over 1, right? And so theta then is the inverse cosine of x. And now we just want tangent of theta. So tangent is opposite over adjacent. So square root of 1 minus x squared over x. Okay. Let's see, arc sine of the sine of 5 pi over 6. What's that going to be? Well, where is 5 pi over 6? On the unit circle here, 5 pi over 6 is pi sixths away from pi, right? So this is going to be 5 pi over 6. So if I take the sine of 5 pi over 6, what's that going to be? Well, remember what our coordinates are at pi sixths, right? That would be square root of 3 over 2 and 1 over the 1 over 2. And so the sine is the y-coordinate, and so that's going to be 1/2, right? So this is going to be arc sine of 1/2, and that is pi sixth. Good. Good. Okay, let's see, now we have the cotangent of 2 pi over 3. So where is 2 pi over 3 on the unit circle? Oops. So this is pi over 2 and this is pi. So this is about pi thirds. So this would be about 2 pi over 3. Right? And so the cotangent is 1 over the tangent. Oh, by the way, what are the coordinates of this point right here? So what are the coordinates here at pi thirds? Right, that's the coordinates here, but just reversed. So that would be 1/2 square root of 3 over 2. But then when you bring it over to this side, what happens? The x coordinate becomes negative, so that's minus 1/2 square root of 3 over 2. Good. And so now the tangent is sine over cosine, which would be square root of 3, I guess. So what would the cotangent be? The cotangent would be 1 over the square root of 3. So this would be 1 over the square root of 3. But, oh, we've got a negative sign there now, so it's going to be a negative. Okay, so that was pi 6 over here. Arc sine of 1/2, and then we take the cosine of that. Actually, we've already done the arc sine of 1/2, right? Because up here we said that the arc sine of 1/2 was pi 6. So we could just replace that. So that's cosine of pi 6, and then cosine of pi 6 is the square root of 3 over 2. Good. All right. So now last one on this page, minus 3 cosine 5 5t. I'm just writing this a little bit bigger so you can see it. The amplitude is the absolute value of this number right here, which is 3. The midline is where this thing goes. So remember that this function by itself is going to oscillate between plus or minus 3. And then when you add 6, it goes to plus or minus 9. Or sorry, that's not right. It's going from, it's oscillating. Here we oscillate between plus or minus 3. But then when you add 6, right, the entire thing goes up by 6 units. And so the 0, which was the original midline, also goes up by 6. So that's the new midline. And the period is always 2 pi over whatever this number is. That's 5. Oops, I ran off the page. So the numbers here would be 3, 6, and 2 pi over 5. Good. Last one here. The curve below shows a function s of t in feet. The problem was with this one was that some of these grid lines weren't visible from the copy machine. And so we said that you could estimate these if you needed to. But let's see if we can't get some numbers here. Find the average rate of change of s from on the interval from 0 to 3. So time equals 0 to time equals 3. And remember that it's s of 3 minus s of 0 divided by 3 minus 0. That's the average rate of change. So s of 3 is equal to 0. And then s of 0 is equal to 5 divided by 3 minus 0. Right, so you get minus 5/3. Oops. I shouldn't be writing right on the edge there like that. Okay. And we know we did anticipate it's negative, right? Because our slope here is negative. Good. What's the instantaneous velocity at time 2? Well, the instantaneous velocity at time 2 is going to be the slope of this line. And so if you were able to read it, you would see like the point here goes through and point here is nice. So then you get this triangle right here for your slope. And so if you go down from 5 to 3, that's going forward from 1 to 2. And so you get a -2 slope. Okay. Find the equation of the tangent line. Well, we've already got the slope of the tangent line. So then the point that the tangent line goes through is the point 2, 3. So the line has slope -2. And so it would look like that. Good. Last one. A cup of warm water at 100 degrees is placed in a room that has constant temperature 5 degrees. 5 minutes later, the temperature of the water is 75 degrees. Use the model for heating and cooling to find a function for the temperature of the water at time t. Good. All right. So our model is that the temperature at time t, hang on one sec. Okay, so I was just double checking some notation. So you could either use, y is equal to a e to the kt plus b, or you could use y equals a times b to the t plus c, either one. In both cases, the environmental, let's see, so how are we gonna solve this? Notice that in both cases, as t goes to infinity, the exponential term is going to go to 0, leaving you with either a b or a c. And so those are going to be your environmental temperatures. And so depending on how you wanted to fit your model, you might say that this is going to be e to the kt plus our environmental temperature, which was 5. Or you could say y equals a times b to the t plus 5. Okay. And then similarly, at time 0, we have 100 degrees. So then you could solve for a or b, depending on which one you want to use. So at time 0, you could say 100 equals a times e to the 0, which is 1, plus 5. So a is 95. In this case, notice that this a is also 95. So therefore, now we have that y is equal to 95 e to the kt plus 5. Or you could have y equals 95 times b to the t plus 5. Good. and then you use the last piece of information for the last constant, either the k or the b. So in 5 minutes, let's see, we're going to use t being in minutes, I think, right? Since it's not defined that way, we can go ahead and say that it is. So t is measured in minutes, and so after 5 minutes we get 75 degrees. So 75 equals 95 e to the 5k plus 5, or you would have 75 equals 95. Now this is where it gets a little bit more complicated, because now you have times b to the 5, right, plus 5. But it's not that much more complicated. In this case you would solve for b, and in this case you would solve for k. Okay, I've run off the page, and I've probably gone off time more than I should. So I'm going to go ahead and stop there. That's not too bad to solve for one of those. Okay, so that's what was going on in the midterm. I guess I'll stop there.